Ever wondered why in space no one can hear you scream? Well, it's not just a catchy tagline for a sci-fi horror movie, it's science. You see, there's a widespread misconception that sound can travel freely in space, just like it does here on Earth. But that's not the case. To understand why, let's first look at how sound travels here on our home planet. Imagine plucking a guitar string. The string vibrates, right? This vibration pushes against the molecules of air surrounding the string. These air molecules in turn push against other air molecules, which respond by pushing against even more air molecules. This chain reaction creates oscillations of pressure in the air, or what we perceive as sound waves. To put it simply, sound travels as mechanical waves, transmitted through a medium. This medium could be a solid, liquid, or gas. It's the air in a room, the water in a swimming pool, or even the walls of an apartment building. But when it comes to space, things work a little differently. Space is a vacuum, not a perfect one, but a vacuum nonetheless. This makes it a pretty terrible medium for mechanical waves. Sure, there's plenty of matter in space like stars, planets, asteroids, galaxies, cosmic dust, and elemental atoms, but these are all separated by vast distances. Imagine plucking that guitar string in outer space. It would still vibrate, and scraps of matter like cosmic dust and gases might be able to propagate sound waves, but the sound would be too weak for our ears to hear. So, the tagline for Alien got it right. While it's not strictly true that sound waves can't travel through space, it is true that humans would not be able to hear those sounds. You could scream all you want in space, but no one would hear you. But when it comes to space, things work a little differently. Outer space, as we define it, is the universe beyond Earth's atmosphere and between celestial bodies. And it's not the best medium for sound transmission. It's a vast vacuum, not a perfect one, mind you, but a vacuum nonetheless. It's filled with matter, but that matter is separated by incredibly large distances. Stars, planets, asteroids, galaxies, cosmic dust, elemental atoms, you name it, it's all there. But even in the densest parts of space, you'd only find a few hydrogen and helium atoms in a cubic meter. Imagine plucking a guitar string in the midst of this cosmic expanse. The string would vibrate, sure, but the sound it produces, it would be too weak for human ears to hear. Cosmic dust and gases might propagate these sound waves, but they'd need to be in significant amounts. So, that terrifying scream in the void of space, no one would hear it. However, there are some exceptions to this Ridley's law. Let's start with radio communication. In space, radio waves, which are electromagnetic, not mechanical, can travel through the vacuum of space. So if someone is talking to you via radio, you could hear them. Once the radio signal reaches your spaceship or spacesuit, it is converted into sound, which then travels through the air in your ship or helmet to your ear. So, in this scenario, you could definitely hear someone scream. Over the radio, that is. Another exception is if you were to experience a physical impact, like a bump on the head while floating around in your spacesuit. The sound waves resulting from the vibration of your helmet and the object you bumped into would travel through your helmet and the air inside it to your ear. So if you hit your head on a floating asteroid, you would indeed hear the sound of your own misfortune. But let's take it a step further. Did you know that even the distant hum of a black hole could be detected with the right tools? Back in 2002, NASA's Chandra X-ray Observatory detected a B-flat note emanating from a black hole in the Perseus galaxy cluster, located a staggering 250 million light-years away. Now, this note is 57 octaves below a piano's middle C, far too low for human ears to pick up. NASA didn't hear the note either. Instead, they saw it as ripples in the cosmic gas surrounding the black hole, caused by the gravitational pressure of the tightly packed galaxies in the cluster. The pitch was determined by calculating the distance between the ripples and their speed. So while space might be eerily silent, it's not entirely devoid of sound. It's just that our human ears aren't equipped to hear